Welcome to the 115th episodes of this channel. So if you haven't subscribed this channel, now it's time to do that so you don't miss any latest updates. And also you can view the all 100 plus videos in the playlist. So if you subscribe to that channel. All right, so today we're going to complete this question using mathematical induction. So this question is 2023 VCE Specialist Maths Exam 1, question 8. So we're given a function is a product x times by e to the power of 2x. So we need to prove the nth derivative of function equal to this statement. So this is the statement. When n for n is positive integer, z plus. So let's do that. So we're going to start with the step 1. So we say, because we need the initial, we start mathematical induction, start initial n. So we need to define what is the initial n. So given n is a positive integer, so therefore n must be greater or equal to 1. So therefore we choose the first n is start with 1. So let's try see if we correctly prove that statement when n equal to 1. So we do first the derivative. So we know that. So we're using the first derivative, e to the power of 2x plus x times by e to the power of 2x, then times by 2. So we make bracket, so 2x in the front plus 1 and e to the power of 2x. So therefore, this is the same as the statement says we need to prove 2 to the power 1 x plus 1 times by 2 to the power of 1 minus 1 e to the power 2x. So that's true. So therefore the statement is true for start n equal to 1. So we prove that. Excuse me. So now we assume, so second step is assumption. Assume that n equal to k, the statement is true. So which means n to the power of k, not a 2, not a power, sorry, derivative, the kth derivative function is equal to, so we're going to write into 2kx plus k times by 2 to the power of k minus 1, so times by e to the power 2x. So we're going to do now step 3, we're using the n equal to k plus 1 term, which is called inductive step. So we will get the k plus 1th derivative is, so let's do the u times by v. So let's do the u dash, which is 2k. That's it. That's the u dash times by v, which is e to the power of 2x. All right. Then so that's the u dash v, then plus u. We copy u down. And times by derivative of v, which is e to the power 2x, then times by 2. So we put a 2 in the front. Now I'm going to, can you see I got this, I got this. I can take the common factor out. So inside the bracket is 2 to the power of k plus, now expanding the brackets, So it'll be 2 to the power k plus 1x plus 2 times by, so k, 2 times by 2 to the power of k minus 1 become 2 to the power of k. So I'm going to put e to the power 2x here. So now, obviously, we can move this one to the front. And these two together, those two terms, very simply put these two together. So we got k plus 1 times by 2 to the power of k times by e to the power 2x. So that's it. That's a proof. That's my n. So that's the first term, and that's the n is k plus 1, then k plus 1 minus 1 is k. So therefore, this is a proof. So therefore, the statement, so therefore the statement is also true when n equal to k plus 1. So therefore, the statement is true for any n. So QUD, proof. All right, thank you for watching. If you like the video, please give us the thumbs up. We will see you next video. So remember, we've got 115 episodes. Please subscribe that to share the benefit.